Good morning, everybody. Good evening, good afternoon, and thank you for joining another Neo4j live stream. And today, I'm super happy to have returning guests. I think this is one of the first ones actually that are eager and brave enough, I guess, and had enough fun last time. They're coming around again for a second round. So I'm very happy to have Christina-Maria Androna and Ioanna Mandilara join me again for join us again for this show on Cypher. So very happy to have you, Christina-Maria and Ioanna. Thank you for joining today.
Hello, Alexander. Nice to be back. Yes, the first time it was a sustain graph. Now it is a CyVer.
Yeah.
Another topic, of course.
Very, very happy to be here again.
Cool. No, it's great. Yeah, we were just chatting a little bit before we get going. I was like, yeah, it was 2 years ago, and I had to
Yes.
look up that link, and I'll post it in chat as well. Where we talked about sustain graph. So that was a knowledge graph on the United Nations sustainability goals in the SDG
Yes.
development project. So
Exactly. Mhm.
yeah, it was very cool. A very very cool project that kind of like went a long way afterwards. So I think I got to see lots of publications also picking that story, and it was a really cool project. Are you still involved to some extent in Sustain Graph, or is that project now completed from your point of view, and you have moved on to something new?
The time that we wanted to create CyVer was about the sustain graph. We want to create a service on top of the sustain graph
Hmm.
to answer natural language questions and get Cypher query. And for these reasons, we ended up with CyVer, which we will present today.
Okay.
It was, yes, it was our test, for example, this graph. And now we're expanding this solution now on another graph databases.
Cool.
Yes, we are still working on it, and a lot of work comes out of it, and we try to sustain it for the future to keep on working on that.
Cool. No, that's great, and I think that's a great project. I like that project a lot. It's really cool, and maybe we don't necessarily talk about sustain graph in this episode a lot, but generally, if people haven't watched the episode, and if people don't know who you are, maybe do you want to give a few words about who you are, what you do, so that people get to know you.
Of course, of course.
Sure.
I'm going to start. We are the Sustain Graph team, of course, as we call it. Uh, yes. Have graduated from the Department of Applied Mathematical and Physical Science of NTUA, National Technical University of Athens. I've also completed my master in data science and machine learning, and we are working together with Christina in R&D projects in the network and management and optimal design laboratory of the School of Electrical and Computer Engineers of NTUA under the project which is called Arsinoi, and is about to provide solutions about climate resilience regions right now. And our main focus is around knowledge graphs, machine learning, NLP, of course, now agentic AI frameworks, all of these. Of course, I like Christina to introduce herself.
Yes, sure. A few words about me. Currently, I'm a PhD student in the School of Electrical and Computer Engineering, and my PhD focus and my research has been on knowledge graphs and their integration in general with machine learning and AI. And at the time I started my PhD, we also started working on the sustain graph.
Mhm.
So since then, I've been working a lot with knowledge graphs and analysis on top of this data. And recently, I'm focusing more, and our research is focused more on generative AI systems and applications. So this combo of knowledge graphs and Gen AI was actually the reason that CyVer was born.
Yeah.
we're really happy to share it with you today, and also interact on it, and with the community, of course.
Cool. Yeah, I can imagine that is one of those things where I was thinking about it back then. Was like, okay, the knowledge graph, when we talked 2 years ago, AI was obviously around, but it didn't play as much of a role. Everything is AI these days. You cannot really, nobody dares to release anything that doesn't have AI.
And
So
in many domains,
sorry.
also in many domains, not
Yeah,
all around.
yeah, everywhere. Exactly. Yeah, exactly. And then I thought, okay, yeah, but, we talked about this in sustain graphs. What's the outlook? And I think you said you wanted to include graph algorithms and make more analysis. And I guess, well, then AI came around and said, yeah, but actually now we have even more things we can do with this data, and we can analyze it some more. So it's cool that you then said, okay, yeah, let's build something on top of this, and use the combination sort of okay, what do we have already in our great sustain graph, knowledge graph, and how can we make it more accessible? I think that's probably one of those
Yes.
goals where
Exactly.
you talk to people that don't have technical background. They don't want to write a Cypher query necessarily to access the data, but they know that there is interesting data right there, but they just don't know what to do with it. And then that's
Yes.
yeah,
And if we want to engage other scientists, for example, we have environmental scientists, it is hard to learn how they how to access a knowledge graph.
yeah.
We want to be able to see the data, to see the analysis, to ask questions without anything. Just type a question. But this is the way, a more harder than we thought. But yes,
But yeah, that's a cool project. And then yeah, I think I saw a post on LinkedIn a while ago when you said, well, this is now here, and then we said, yeah, we have to do another episode now, because this is also another cool project, and specifically around this whole topic. It's for us, it's something we try to encourage people to learn Cypher, to learn, to work with
mm,
Neo4j. We have the whole of June was like of this month, which people to do the certification and to do a Graph Academy course. But I understand that it is still some kind of a hurdle, and
mm,
with if AI systems getting better and better, at some point you don't necessarily have to write full queries. You can type text to Cypher, um,
yes,
but it is still, it's not validated, and it comes up with, you'll be talking about this now. So I think it's
It's
very helpful to have,
challenging for the
yeah,
developers also
also for the
make it
developers. Yeah,
accessible to
yeah,
the end
yeah,
users.
yeah. Yeah, so that definitely, I like that. I think that's really cool to have this capability, and then say, okay, yeah, but I've written this Cypher query now. Is it good? Is it performant? Can I actually use it? And just to have this another loop in between before I actually execute on it. That's super cool.
That was the motivation also for CyVer.
Yeah,
and we're also gonna show you some results of our first paper where we introduce Cyver for these tasks in the presentation today.
cool. I'm looking forward to that. So as always, I just wanted to make sure that everybody, if you're new to this channel, or if you're new to these live streams, we are obviously live. So if you have questions, feedback, comments to Christina-Maria or to Ioanna, or generally about CyVer, or on anything else, just use the chat. I'm always happy to have a look at your questions, at your comments. Happy to see you all here. And if something comes up afterwards, you can use the comments on the video. But ideally, we can have a little conversation today as well. But you know I'd like to hand it over to you two. I don't know if you said you had a presentation, so I'm guessing you have a
Yes,
couple of.
Mm-hmm.
we have a presentation, and next we are going to show you a small demo around the Cyber, how it
Super.
works.
That sounds very good. Yeah, I'm looking forward to that. That's really cool.
I can share my screen
Mhm.
with the slides. Um,
Yes.
okay.
Here it is. All right. Let's go here.
So let's see if it works with the presentation mode.
Yeah.
Hmm.
Let's see what it says. I'm seeing your deck, not
Yes.
the
Yeah,
presentation
but
view.
I cannot select the present to present it. Let me stop and share again.
No.
Hmm.
Maybe you need to share the whole.
Yeah, I did, but mm, I don't know why it doesn't let me.
Maybe to share the PDF, Christina, of the presentation.
Uh, yes, or you can have the presentation,
Or we
and
try.
you can share it. I mean,
Okay.
and I can share then my screen for the demo because it doesn't let me present.
Okay, now, so do you want to share my screen or to try the PDF version?
Uh, no, give me one moment to try again,
Yep.
and otherwise you can share your screen.
Yeah, we can. Let's see how it goes. Should be working. But sometimes, you know.
Yeah. Okay, I will try one more time because now
Okay.
let's see it cooperates.
Yeah, no problem.
Okay.
No problem. Here it is.
No,
Okay.
it's still okay, now. Great, we did it.
Okay, perfect.
Perfect. Can you click on hide on the little pop-up
Yes.
from
Sure.
that? Yeah.
Great.
Yeah. That looks good.
Okay,
I can
perfect.
probably zoom in a little bit, maybe. Wait,
Perfect.
s- wait. Yeah, maybe let me go here to this view.
Okay. I will start first.
Hmm.
Uh, so I am Ioanna Mandilara. I am here with Christina to present CyVer, our tool to verify Cypher queries. Christina, if you next slide, please. Okay, so we are from the Network Management and Optimal Design Laboratory of the School of Electrical and Computer Engineers of NTUA. And we are working, as we already said, at the Neo4j project, which is a European Union Horizon Innovation Action Program. Next slide, please. Thank you. So the main task or problem that we want to solve is called text to cipher. The text to cipher task is a task where a user asks a natural language question to an LLM, and the large language model responds with a cipher query, which is called generated cipher query. So, three main questions arise when we deal with this problem. At first, can we really trust the LLMs? Are they reliable enough to generate a correct cipher query without the intervention of a human? Second, what about the hallucinations? The hallucinations of the LLMs refers to the phenomenon where an LLM produces an output that is factually incorrect but sounds correct. So in this case, if you are familiar with the text cipher task, you know that the LLMs often produce or make up non-existent labels, relationships, or properties of the cipher queries. And at last, when we present at the Cypher, at the LLMs, the prompts, the schema, and the properties, do they really understand the schema? So, or they are just predicting some patterns without true comprehending? So these three questions we ask ourselves to see if we are going to be able to answer. Next slide, please. Okay, so our motivation or our journey. At first, we wanted, as we already said, to enable non-technical users to interact with our graph database. In our case, it is called Sustain Graph, and we wanted to increase accessibility and usability of the Sustain Graph, and in general of graph databases. To do this, we have to select a model, and especially we want to select an open source model because they are transparent, customizable, and cost effective. And when we search around the metrics that exists, we found that they are primarily assessed string similarity, like the blue score, Russell, or the similarity of the output of the Cypher queries, for example, pass1, pass-k. And for this reason, after these three main steps, we ended up with CyVer. And as a spoiler or tip, if we provide to the LLMs the error types that they are made, they are going to improve their answers. That's the deal. Let's move to the next slide, please. Thank you. Thank you. So we introduced CyVer. CyVer is open source and is a Python library designed to validate Cypher queries against the knowledge graph schema Neo4j. It ensures correctness in terms of syntax, schema validity, and property access. We use regex patterns to detect node or relationship or paths in the Cypher queries, and also comes with a key feature which we call path pattern inference, where it detects node labels or relationship types to the undefined variables declared in the query. You can also find two QR codes here where you can install CyVer direct from our GitLab repository or the Python package index. Next slide, please. Thank you. So, what CyVer offers? CyVer offers three main classes: syntax validator, schema validator, and properties validator. All these three classes comes with a validate method, which in the case of the syntax returns a Boolean variable that indicates if the query is syntactically correct or not, and in the case of schema and properties validators, returns a score in the range of 0 to 1. Also, the two validator schema and properties has an additional method, the extract method, which in the case of schema validator returns a list of the extracted node, relationship, and path patterns, while in the case of the properties validator returns two mappings that maps the variables declared in the query with the access properties and the labels or the types of the relationship or nodes with the access properties. But I will explain it later in more detail. So next slide, please. Okay. Here we have the first method, the validate method of the syntax validator. As I already said, it returns a Boolean variable which indicates if the query is correct in terms of syntax. But it also detects conflicting labels in node relationships. And we can take an example of a small graph. For example, we have here two nodes, goal and target, which have the properties code, title, and description, and are connected through the relationship has target. We can see on the right that the first query assumes that G variable might be goal or target. This is the case of the conflicting labels. So in this case, this method will return false and raise an error, while on the left side, we have a correct query. As you can see that match n G goal return count G as output is correct in terms of syntax. Also in this slide, we saw an example of incorrect query for undefined variable. The second query here has a variable w which is undefined. So in this case, also the validate method will return false for the syntax correctness. Next slide, please, Krishna. Thank you. So now let's dive into the schema validator. Schema validator, the extract method. The extract method returns three main lists: one from the node for the node patterns, one for the relationship patterns, and one for the path patterns. We take again the same example, and we are going to see the example query where we want to match the n has target with a t target, and we want to return n. Here we have that at the node patterns, we have the nodes target, as you can see. The relationship patterns has target, but at the path patterns, we can see that the list consists of a path goal has target. In this case, we can see that we didn't assume that in this query that n might be goal. But here comes the key feature of CyVer, which is called CyVer pattern-based inference, which uses this function to guess missing node labels or relationship type by using the provided schema to the extract path patterns. Next slide, please, Christina. Now let's move to the validate method of the schema validator. As you can see, this method returns a score in the range of 0 to 1, which reflects the average of non-empty valid extracted node, relationship, and path patterns. These scores also consist of three main weighting factors, W1, W2, and W3, that depend on the extracted components. We can see some examples to understand these components in the score formula. For example, in the first query, we have a relationship has target 1. This relationship has target 1 does not exist in our schema. So, as you can see, we have a wrong relationship patterns after the extract method and a wrong path pattern after the extract method. And as you can see right now, the weighting factors are equal to 1/3. And because we want to take an average of the non-empty extracted nodes, paths, and relations, and here we have three lists non-empty. So in this case, the validate score will be 0.33. But I'm going to show you another example where the weighting factors are different. So for example, the second query. The second query does not have any relationship type. So for this reason, after the extract method, we have an empty list on the relationship patterns. And here, the weighting factor 2 will be equal to 0, while the two others will be equal to 1/2 in order to have a score of 1, because this is a correct query and we want to give 1 score, not lower than this. Next slide, please, Christina. Thank you. Now let's see the properties validator. The properties validator, the extract method, returns two mappings, as I already said. The first mapping maps the undefined variables in the query with the access properties, while the second mapping returns the node labels or relationship types with the access properties. In this query that I provide, we can see that the code property, that the target has an access property code, and the n variable has an access property called title. And here we can see that the first mapping maps the n variable with the title property, while the second mapping maps target with a code property, while maps also goal with title. Again, we have the pattern-based inference where CyVer guess that n is goal according to the schema. So here we have that goal is mapped with title. And now let's see the validate method of property. Here we have again a score in the range of 0 to 1, but with different formula. This formula indicates the percentage of correctly accessed properties. If the total access properties are equal to 0, then this score will be none. And we can see the two examples to understand more. So in the first example, we can see that the n variable has an access property called title1, and the t variable, it has an access property called code. The title1 property is wrong. So in this case, the score will be 1/2 because we have one correct property and one wrong property. While in the second case, the second example, we can see that we have an example that does not access properties at all. So in this case, the extract method will return two empty dictionaries, one for the variables property mapping and one from the labels property mapping, and the validate method here will return a score of none. Now I'm going to give the floor to Christina to present you some results of our paper, which is called Decoding the Mystery, and the small demo, and the new release of Cypher with the errors.
Thank you, Ioanna. So, as we also mentioned in the beginning, the main reason that we developed CyVer was to be able to evaluate the Cypher queries that were generated by large language models. So, in the recent work of ours called Decoding the Mystery of How Can LLMs Turn Text into Cypher in Complex Knowledge Graphs, we developed a metric-based LLM evaluation framework in which we tried to evaluate several open source mainly models in the text to Cypher task. So for this reason, we developed a dataset of natural language questions with their corresponding Cypher query based on the sustain graph, the knowledge graph that we mentioned in the beginning about environmental and climate change data. So through prompt engineering, by giving as an input to the LLM the natural language question, the instructions to generate Cypher queries from natural language and the knowledge graph schema of our database, we collected all the generated Cypher queries from the LLM. So the next step was to evaluate these Cypher queries on a set of metrics. Several of these metrics were more traditional NLP metrics like Jacquard, Tajaro, Blue, Ruse, or also exact match. But we also took advantage of the CyVer validators regarding the syntax, the schema, and the properties that these generated queries access. So in this way, we were able to evaluate their performance. So as we can see here, we selected 13 open source large language models and the closed source model of OpenAI GPT-4o in order to evaluate them on this dataset. We can see in this bar plot the performance of all the models and their success rate of the generated Cypher queries. So we grouped these models into three categories. First, we grouped into a small-sized LLMs with open source models ranging from 2 to 3 billion parameters, medium-sized LLMs 7 to 8 billion parameters, and larger ones, but lower than 100 billion parameters, as well as GPT-4o. So the first thing to look at is how many of these generated Cypher queries were syntax correct. So as we can see here, generally in most of the models, the syntax correct score was relatively high, around 70% or more, even for the smaller sized models. However, if we look at the exact match, which is the metric that showcases that the generated query was actually executed and returned the outputs that we expected, then we can see that the score is very low, and especially for small or medium-sized models. Actually, only Quen 32 billion parameters and 72 billion parameters, as well as GPT-4o, managed to achieve a pass-1 rate over 50%. But we can see from these two metrics, syntax validity and pass rate validity, that the one is too strict, like the exact match, and the other one is too loose. So we want to see how actually the model performs and if it respects the knowledge graph schema that we prompted. So that's why we introduced the knowledge graph valid query rate, where we evaluate that the Cypher queries generated were not only syntax correct, but were also schema valid and properties valid. So we can see here that actually the score raises compared to the exact match or pass-1 rate, however, is of course lower than the syntax valid one. And we can see here that even this rate showcases that the small-sized LLMs actually do not respect, not even at 50%, the knowledge graph schema that they get as an input. But now, having CyVer in hand, we can see actually where do the LLMs fail when they generate Cypher queries. So here in this plot, we can see the distribution of syntactically correct generated queries across their different schema and property validator values. So we selected several models from all the groups. And an obvious pattern is that as the model size increases, the schema and properties validator values are closer to 1 for most of the generated Cypher queries. Actually, we can see here that only GPT-4o manages to fully adhere to the knowledge graph schema given and do not hallucinate any labels or relationship types or paths. But we can see a pretty good behavior also from Quen 32 and 72 billion parameters. However, if we check the properties validator, we can see a different pattern where GPT-4o actually fails to respect in all of its queries the properties that are named in the knowledge graph schema compared to 72 billion parameters that never fails. And an overview of these bar plots is that actually smaller models, and especially Llama 3 billion parameters, has more and more queries with lower properties and schema validator values. But we wanted to know and investigate why actually these models have low values in schema and properties validator. Is it because they hallucinate labels, relationships? Is it because they make up paths or wrong directions? Or they give wrong pairs of label and properties? So that was a motivation of ours that we wanted to dive into. Moreover, there is a shift lately, moving from naive RAG on graph databases and single shot querying to the LLM to more agentic AI systems that they give feedback on the LLM when it generates queries. And the LLM then will go to a self-correction loop that will try to refine the generated query. Most of the times, though, we see that the evaluator of these queries will again be a large language model as a judge or as a critic. And still, we don't know if it is trustworthy or if it will hallucinate in the evaluation. So that's why we wanted CyVer to be in the role of the judge, since CyVer is more deterministic and executable aware. So for these two reasons, we introduced a new version of CyVer, where we added explainability on syntax, schema, and property validation scores with error metadata. And we also added several suggestions on how to fix these errors on the Cypher queries. So to develop the second version of our CyVer, we leveraged the existing Neo4j notifications, warning, and error codes, but we also introduced some new errors and warnings. Here we can see an overview of the categories of errors that CyVer detects, actually the syntax validator, and provides some metadata. Firstly, of course, it returns an error when the Cypher query has a syntax or an execution error. If a parameter is not provided, if a relationship type expression cannot be satisfied, if there is an arithmetic error and actually an explicit division by zero, or if there are variables with conflicting labels. The schema validator, on the other hand, throws an error when some label or relationship types are unknown to the knowledge graph schema, or the path does not exist, or it has a wrong direction, or the variable length is wrong. And finally, the properties validator throws an error when the property is unknown and does not exist in the knowledge graph schema, or if the pair of label and property is not correct. So for the next thing, we have prepared a demo to show you how CyVer works and how actually the metadata are returned as feedback.
Okay, cool. I think we can take the time and answer a couple of questions while you're getting ready. There is, let's move over here again. Getting one question from Olaf. Olaf asks, what historic language family would you classify Neo4j as? And I'm not sure if this is if he meant actual spoken languages, probably not, but more like in terms of how Cypher as the query language works in. I think Cypher is a unique language in a way that it is quite specific, if derived from this ASCII art background, but it takes I think it takes a lot of inspiration from SQL, but tries to make it easier and more approachable. So it's some of the wording, some of the syntax is going to be feel like familiar if you are coming from that background. Some of it is new, some of it is specific for graph databases for Neo4j. And on the other side, I think considering that the ISO standard committee has decided that graph query language GQL is now its own standard, which is where Cypher is based on now, shows that there's a path enough or a distinction enough to give this separation between SQL and graph query language, or GQL as they call it. I don't know if you have an opinion on that. How do you think how do you compare Cypher with other query languages in the database world?
I would say that it might be similar to SQL, but I think it's more someone can understand it better, and the intuition is easier since it is represented as a graph, and we can go through all the path and the connections that exist in this graph.
And also, it's more free in terms of the writing. I think that SQL is more strict. We have to use specific clauses. We have to do specific operations. Cypher is more, how can I call it, open on this. Has many ways to write a Cypher query.
And customizable for this reason.
Then they have two questions that go sort of in the same direction from Eshwa and from Olim. It's about the validation part, and you explained this a little bit, but maybe you can go a little bit more into that and say, okay, how does Cypher know? How do you validate the syntax then being ready? Do you feed it, lots of queries that are correct? How is that mechanism working? Maybe you can explain that one more time.
Okay. In terms of, we're going to show you in the demo these examples.
Yeah, or maybe.
But yes, we have used regex patterns to use to detect paths or relationships or nodes in the queries. So when we have the extracted nodes, paths, or relationship or properties, we then end up with validation. We have a score when we say, okay, I have two correct path patterns because yes, I have executed in the graph database with the query does not uh, match the specific patterns to give us some results, but it uses explain, for example, to give the results, and we test this path pattern exists in the database. We then get true or false. So we have our validation then, and we came with the correct ones and the false ones. We apply the formulas, and then we get the validate score. I don't know if
I would also like to add that in terms of the syntax validators, we use the explain clause in order to make sure that the query can be executed and it is syntax valid, but without actually executing it.
Okay, yeah, that makes sense.
And I'm not sure if the question was also about the inference. So I will again show something in the demo, maybe is more straightforward, but actually the inference of missing nodes or relationships is actually based on the Neo4j schema.
Okay.
So it will only inference a label based on the Neo4j schema, as also it would be executed. When you execute a query and the label is missing, you can still execute it because it is inferred as the label that the Neo4j schema offers.
Okay, cool. Let's do the demo. I think that will make things clearer.
Sure. I will share my screen again. Okay. So should I zoom in more, or is it okay?
I can zoom in a little bit more from this perspective.
okay.
I hope that, and maybe even I can zoom in some more. I think
I
this
also
is,
zoomed in.
yeah, okay. I think this is readable now. Yeah. Let us know in chat if this is not readable, but I think this is, get the logo out of the way here as well. I think this should be fine.
So in this demo, when someone wants to use CyVer, we just import the three validators. And the next thing to do is to connect to our Neo4j instance with the Neo4j Python driver. So through the credentials, we connect to the Neo4j instance. For this demo, we will work on this small part of the sustain graph, which just here 3 entities: goal, target, and indicator, and the entity geo area that's also multi-label as area. So first off, with the syntax validator, we have our query here, and it just matches the label geo area, and we initialize our syntax validator. So by using the validate method, we can see that the returned result is that it is syntax valid and there is no error metadata. But for example, here, if I delete this return variable, then this query is not correct anymore. So the syntax validator will return. Now I don't have, I'm not connected to the right database. So give me 1 second.
Yep, no
maybe
problem.
To stop the screen and re-enter.
Yeah, maybe.
Okay.
No,
Right.
no problem.
Everything happens
time
when
Is this live? This is what it is. Yeah. I mean, yeah. No. don't worry about it. It's all gonna be fine. We know how this goes.
But
So yeah.
the important thing is to be able to connect to your Neo4j instance. Otherwise, you may see an error like that.
Yeah.
So it's also
Good we covered that as
weird
well.
because it is not not connected to it. Okay, now I think I can reshare my screen. Okay.
Okay.
So moving on. Now, the syntax validator, I will hide this also, will return false since this query is not correct anymore, and will also return that the error is due to a syntax error, where after return, there is an invalid input of an empty string and something else is expected that would work. So in this case, it's like a feedback of how we could correct this Cypher query.
Mm-hmm.
Again, we showed also in the slides that if a parameter is given and no value is given for this parameter, then this query cannot be executed. And that's why the syntax valid will be false and the metadata would be that the parameter was not provided, also indicating in natural language that the missing parameters is this one, in our case, code param. The next error type refers to relationship types, expressions that cannot be satisfied. So for example, here I added this and has relationship type. So I will get a false syntax and the multiple error metadata. First one, because the parameter is not provided from here as before, but also an unsatisfiable relationship type expression error, indicating specifically that this is the error that cannot be satisfied as a relationship.
Okay, that's cool.
So moving on, we also detect when an arithmetic error might occur if we execute this query by using regex to discern patterns with explicit division by zero. So we detect several patterns. And we can see here that the error that would get would be an arithmetic error of division by zero. And finally, another feature that we introduced was to detect if a variable is assigned to multiple labels. So in this case, for example, the variable g is assigned to both geoarea and goal. So this would be an error, actually a conflicting variable error, with variable g having two labels conflicting goal and geoarea. However, there are databases where there are multi-labels. So that's why we have these check multi-label nodes options, where we are able to validate if the two labels mentioned actually refer to the same entity.
Oh, okay.
So it's here in the example that I showed you earlier that actually geoarea and area are the same entity. So this query will be able to be executed. And that's why the syntax validator is true with no error metadata.
That's very nice. Yeah.
So I will move on to the schema validator. I don't see any questions on syntax validator, so it might be good to continue.
Yeah, let's continue, and then I see another question, but let's cover that after the demo.
Yeah. Okay. So regarding the schema validator, let's work with this query that accesses the entity's goal, target, and indicator. So by initializing the schema validator, we can access both the extract and the validate method. So as Ioanna presented earlier, the extract method detects the node patterns, relationship patterns, and path patterns in the query. So in this query, it detects all the nodes, their relationships, and the paths. And the validate method works on the extracted patterns. And in this case, everything is correct. So our validation score is 1 with no metadata. The inference feature that we mentioned earlier is that, for example, in this case, if I remove this label, then the schema validator, based on the path, will infer that this variable t, which is now assigned to a label, it's not detected as a node. However, it is detected as a label in the paths, since it is the only label that would be valid for this path. And again, the schema validation score will be 1 with no error metadata. However, if a label that we provide, in this case, goals instead of goal, or a relationship type has indicators instead of has indicator, which are do not exist in our Neo4j schema, then we will get a lower schema validation score, depending on how many nodes, relationships, and paths were accessed. And these types of errors, the first one refers to an unknown label warning, where it indicates that some of our labels do not exist in the database schema, and it also showcases which is the wrong one. And the same thing for the relationship type, which showcases that this relationship does not exist in our Neo4j schema.
Cool.
And should be corrected. Another interesting feature about inference is that, for example, in this query, where we have the label goal that it is connected to any node label or through any relationship type, the schema validator actually only extracts the goal as a node, but then through its inference feature, it will return anything that matches here the path inferred labels or relationship types. And actually, if there are many options, and in the sustain graph, there are a lot of one-hop paths from the goal, we will see that if we run this multiple times, we might get some different outputs here as the extracted paths. So the inference here will be goal has indicator. If I run it one more time, I can see goal has target, etc. However, the schema validation score in this case is always 1 because always the inference path pattern will be correct. We cannot infer something that is not valid. And of course, if the query contains labels and relationship types that are not actually connected as a path in our Neo4j schema, the schema validator will return the error of unknown path warning. So in this case, that the path goal has area is not valid for our schema, we will get that this does not exist in our knowledge graph and it should be changed. If the path, however, exists, but the direction is wrong, which is a very common case when LLMs generate Cypher queries, then again, we will get a wrong direction path warning, indicating that this should have the opposite direction in the knowledge graph. And we also indicate the way that it should be changed to with the opposite direction.
That's cool.
Then moving on to the properties validator. Again, we have these two methods, extract and validate. The extract method returns what Ioanna also mentioned, the mapping of the labels with the properties they accessed, and the variables which are not assigned to a label with the properties they access. So in this case, we have this variable g assigned to the label goal, and they access the properties title and code. So we get here that the label goal accesses these two properties, and these two properties are correct for our label goal, so the properties validation score is 1 with no error metadata. However, if, for example, I provide here a property that is valid for existing the Neo4j schema, but goal does not have this property, I will get an invalid property accessed by label warning, meaning that the label goal does not have this property.
Yeah, okay.
But if I access a property that does not exist in the sustained graph at all, in the Neo4j schema, names, for example, I will get this error that the goal does not have this property, but I will also get the unknown property key warning, where it indicates that this property, names, does not exist in my schema.
Okay. Yeah.
And the inference feature is also part of the properties validator. So in this case, we have this path that goal has target T, and T, which is not assigned to a label, accesses a property. So we will see it here in the extract that is mapped to this property code. This means that we have to infer this label in order to validate if the property access is correct. So what we do is that we check in which path this label belongs to. In this case, it will be inferred as a target. And also, if the properties they access affect the label of the inferred label. And in this case, it is inferred as target. And actually, target also accesses, has the property code, and therefore the properties validation score is 1. And if we had, like in this case here, to infer a label that could be any label of our graph, then the only thing that filters the label and we have to infer it is the property that it accesses. So in this case, the only label that has data report property will be the EU policy target entity, and that's why it is inferred as this, not any other label. So now I will get to a little bit more tricky part regarding inference with properties. If we see this example, we may see that this variable could be any label of our graph. And we see that it accesses 3 properties: code, description, and EU code. However, there is no label in our graph that has all of these properties. So now we need to define the behavior and what we want our validator to do. We have this parameter called strict that tells us that if we have to infer a label and this label is not valid for all of the properties that this variable accesses, then we have to pick the label that accesses most of the properties correctly. So in this case, we get that A is the label goal that accesses code, description, and TU code. However, only code and description are valid for this label. And that's why we get a property validation score lower than 1. And of course, with the error that the label goal does not have the property EU code. However, there is also the option to set strict to true. And this means that this will be inferred to a label only if this label accesses and is valid for all of the properties that the variable accesses. So in this case, it will be inferred to no label. And since we have no labels to validate, the properties validation score will be none.
Okay.
So a few things about how a properties validator handles labels in disjunction, like this one here. In this case, both of the labels are correct and they have the property code. So that's why in the extract method, we may see that the target and the indicator access the property code and the validation score is 1, since it is correct for both. However, in a case like this, where the code is only valid for the label target and not for the area, we will see in the extract method that only target accesses this code, and the schema validation, the properties validation score again is 1. And finally, if the query adds a label in negation, then we have to infer the labels of this query, which will be any label that is not a target, that belongs to this path, and also accesses the property code. So in this case, it is inferred as this list of labels, which are all valid for this path and have the code property. So that's why the property validation score in this case will return 1 again. So I think I went through all the demo. I don't know if there are any questions.
That's cool.
We can go
Thank you
through.
very much. Very nice, and I think that's pretty powerful already. I see, and we're already at the end of the hour, so maybe we can do two quick questions because I think they are interesting to come up, and I think you covered one of them already. Eshwa asks, how do you calculate the validation score again? Can you quickly recap that?
Uh,
Per- Perhaps we can
sure, maybe I should go to some. No, yes, Ioanna, you can,
do the slides.
but I can give an example.
We wanted to explain
Okay.
the validation scores of all the validators, syntax, schema, and properties. Let's see the schema validator, for example. Okay, then next schema validator.
This one.
The validate method. Okay, here is the formula.
Yeah.
The schema validator offers three lists regarding the extracted nodes, as Christina already showed, the relationship patterns and the path patterns. If one of these lists are empty, then the corresponding weighting factor of the corresponding weighting factor will be equal to 0 in order to have equal distribution across the extracted components, because, for example, a query might not access at all a relationship or not access at all a path.
Mm-hmm.
Perhaps it might be a query match and goal. This query does not access paths. So in this case, the weighting factor 2 that regards the extracted relationship and the weighting factor 3 that regards the path patterns will be equal to 0, and the weighting factor 1 will be equal to 1. So this course depends on the extracted lists and is equal, the weighting factor are equal for these lists to get a correct score. If we have, for example, at the first query, one half, at the second query, 1/3, then this will be wrong because the score will be different. And this query, as we can see, example query 2, is correct regarding of schema. It accesses a node that is called goal, a node that is called target, and an undefined relationship. For this reason, the weighting factor 2 will be equal to 0, and we have the score of 1. And as for the properties, of course, you can interrupt me if you want to explain more something about this formula.
No,
And
I think that's great, and
okay.
Can
And regarding the properties validator, the validate method, next slide. Okay, here we have the correct access properties. For example, if we have three access properties where two of them are wrong, then we'll have a score of 2/3 because we have two wrong across three total properties. If we have a query that does not access at all any property, for example, the second query, then the score will be none because we cannot give a score of 1 or 0. It is none because it does not access any properties. So this is the formula for, I think for properties is more clear than the schema.
Yeah, cool. Thank you. There's another. Well, it's not really a question, but more of an encouragement, I guess, from Yuri. You better implement this in libraries if it's really useful. Are there any packages that have CyVer already as a dependency? So if you're building with Neo4j building and writing Cypher queries. Do you have something like that in the works, or do you know of anything?
We know that actually CyVer, it is built as a package, and someone can download it from the Python, the Python index. I do not remember the name. There is also the link. We don't know yet if there is a dependency on CyVer from other packages, because it's an early project. Actually, we released it a couple of months ago, but we hope
Yeah.
that they will use
No, I mean,
this.
yeah, maybe today somebody watched this, and then if it's great to incorporate that.
And actually, also it's open source, and we are happy for contributions and feedback on it. Of course, if you want to open an issue or create a pull request, more than welcome. It's an ongoing project, and we are still working on it and adding features, fixing errors,
Cool.
etc.
I added the GitLab and the PyPy links both in the video description on YouTube, so you can always find these links there. And just to round us out, I think the last question comes in from Adrian. Adrian asks, because you showed earlier number of errors, and then the various error types you have, and he was wondering if these error types were evenly distributed, or did you find specific error types happening more often than others?
Actually, at the time that we evaluated the models, we only had the validation score of CyVer. So we could only see if a module fails in schema or it fails in properties. And that was the motivation to move on to error metadata. However, in the publication, I think there's also the link there of decoding the mystery. We have made an evaluation of the errors by checking ourselves the generated queries. So there are several categories of each model, what kind of errors each model ended up with in its Cypher queries. However, now CyVer offers the opportunity to have this categorization of errors through its own feature. And that was also the motivation that we ended up with the second version of CyVer and all the errors metadata.
Cool. Okay. Super. Yeah. I think with that, we have reached the end of the session today. I can only say thank you very much again to both of you for participating, for presenting the CyVer today. I think it's a great tool. I hope, like Yuri says, hope people are now contributing, maybe building with your package. That would be great to see. Really, really cool, and hopefully that helps a lot of people in the end, in the long term, to be more, feel more comfortable if interacting with a graph database via Cypher to get queries written and to query that data, and don't feel scared and like, oh, I don't know what's in my data set, and I don't know how to work that as a graph. So that's hopefully that's helping a lot of people. So thank you very much for doing that.
Thank you for having
Thank
us.
you to Alexander very much.
Next up is the 2nd of July, our Graph Talk Pharma and Life Sciences. We will live stream that. I share the link in chat as well. If you're interested in joining that, we'll have a full day on presentations, on technical presentations from Neo4j users and customers, and presenting about what they're using, how they're using Neo4j with Gen AI as well, but also generally in the pharma industry. So I think that should be a very interesting day, full of interesting presentations. I think I mentioned this earlier. We still have our graph certification month, or our training month. So with a final session tomorrow, pass the Neo4j certification exam like a pro with Jennifer. We'll do that tomorrow, and go through some tips and tricks on how to become a Neo4j certified developer. Nodes is coming up. So I think you also presented at Nodes a while ago. Maybe you want to, I don't know, the call for papers closed. I don't know if you submitted, maybe you did, hopefully. And then we are currently evaluating, but if you are interested in interesting technical sessions all over the place, from applications to AI to data intelligence or visualization, register for Nodes. It's happening on the 6th of November. And yeah, anything else, join the Neo4j community, get your projects out there, let us know what you do. Maybe you'll show, be part of one of these live streams in the future. Try Neo4j Aura via the Aura free program, where you can get an Aura instance graph database as a service free of charge. Or if you want to learn more how to improve your Cypher queries, if Cypher gives you lots of errors and you think, okay, I can do better than that, then you need to go to Graph Academy and enroll to one of those Cypher fundamentals courses and learn a little bit more. Yeah, again, thank you very much, Ioanna, Christina-Maria. It was a pleasure having you too. Thank you, everybody, for watching. Have a great rest of the day, rest of the week, and yeah, I hope to see you soon in the future, somewhere around Neo4j.
Thank you too. See you